Hello, everybody. So we have a few questions we're going to solve here from the review. We have 4 questions, but 2 of them are the same. This first one, which is the finding the half life or a double life. I'll explain both. It's same as the number 39, so we'll just solve this one, then do the other 2 in this video. So let's do this focus mode here, and hopefully it picks up. Okay, cool. Just to explain, the amount of money invested in a certain amount increases according to the following function, which is this one here, and where y0 is the initial amount. And I posted this one here, it explains the whole thing. So y is the amount at a time t. So if t is 3 years, then y is the amount at 3 years, or the final amount. Y0 is the initial value, or the initial amount, or at t equals 0. So if you put t is 0, this becomes E1, which is, so it becomes just 1. So in this case, y equal y0. E is a particular constant that's irrational number, which is your number, and you can find it in a calculator. You can do this on a calculator and you get that number value. So you're not supposed to round it, just use it directly in the calculator, because it's non-terminating number. It's not something you would round. R is the relative rate of growth, and R can be greater than 0 or less than 0. So if it is less than 0, then it's a decay, something decaying, and if it is positive, then it's something growing. All right, and T, of course, is time. So here for the question, so the question would ask either half-life or double life. In this case, after how many years will the initial investment be doubled? We know if something is double means twice. So if something is 10, doubled means 2 times 10, which is 20. So if y0 is the beginning, right? So you ask the question, what does it mean when it's double? If y0 is 20, then it's 2 times 20. If y0 is just y0, right? Some say why not as well, but for this course we'll just say y0, which is the initial value. So if y0 is the beginning, when it's double, what happens to it? It becomes 2 times y0, right? So that's kind of to figure out. So let's write the equation here. We have y equal y0 e to 0.035 t. When the y will double means when y will become 2y0. So if y0 is 1,000, when y will become 2 times 1,000, which is 2,000. So we set it up that way. And since we have the same variable here, that's not 0, because for this investment or whatever it is to happen, y0 has to be an amount, it's not 0. So we can divide by y0 to cancel it. So that's why we're allowed to divide this. So since y0 cannot be 0, because it has to be an amount for us to talk about this whole thing. So we can get rid of it by dividing both sides by the same thing. If we divide by the same thing, both sides, then we're not breaking the balance here. So when you do that, what's left? 2 equal to 0.035 t. We are interested in this. When is it time for it to double, right? So we're interested in t. T is here in this exponent part, right here. and we need somehow to get it down here to say t equal to this, right? So we can take the natural log to both sides, since the natural log is the inverse here, and it will cancel the e, kind of. There are a few ways to do it, but the simple way we talk about it in properties is to just take a natural log to both sides. So take natural log to both sides. And so we do ln 2. So this is one quantity. It's not two parts. It's one part, one quantity. And ln save the here e to t, right? So this is one thing as well. So what happens? Anytime you put, we did this with inverses. Anytime you compose a function with its inverse, you get x. So anytime we put a function with its inverse, we get the input. So what happens in this case, anytime we do that, like you start with x, you get something here, then it gets returned with or whichever way you want to do it. It doesn't matter. So some will say, I'm used to it this way. That's fine. So you get something here, and the inverse will take it back and return it. So so all these rules apply, and this is we've done this different times, and we compose a function with another function. But a special thing happens when you compose a function with its inverse, or you compose the the inverse with the function. Same thing happens. So, and that's what's happening here. So either you're going to cancel them, or you can apply the power rule. If you want to do that, that's another way. But we need to keep the idea why we take natural log in the first place for both sides is because we want just to cancel this thing, right? If we want to use a power rule, then we can take some, we have some other options. But so this thing is 1, so 0.035t ln 2, or natural log of 2. And we've done equations. If you have 2 times x, you divide by 2 to get x by itself. So same thing here. We'll divide by this number to get t by itself. So this is the exact value of time. When you cancel it. So this is the exact value for the time. After that is a matter of doing it on a calculator. So I think it says round your answer to the nearest tenth or one place, right? So let's do this here. 2 natural log divide by 0.035. We get 19.80. So it's 19.8 years. All right. So here we didn't have to know. So the question here, we didn't have to know y0 value, right? So that's where the confusion sometimes happens, and why this problem looks difficult, because you'd be like, you're asking me for something that's going to double, in certain time, and you ask me for that time, but you didn't tell me how much it was in the first place, right? So that's where the difficulty is. But the trick here is to use that relationship of here when it doubles. So let's change color here. So when it, in this part, to get rid of it here. So that's the trick, is we don't know it. Since we don't know it, we want to get rid of it. And in this time it works. And so when you read the problem, you see what it is about. So T in years. So if the question asks in months, then we need to convert these years to months. So it's always worth to look at the details. All right, so we're going to look into another question. This is a little bit different than the other one. Solving a work problem. This is a very interesting problem that has to do with work, and kind of if you get an idea, for example, for teamwork, which is if the team is efficient, it will do the job in less time. So that's one idea to get from these. So left on together, so the cold and hot water faucets. So let's say you have a sink, for example, and you have two faucets, and let's say the cold all right. For a bathtub take 4 minutes to fill the tub. So if these both together, so that's the idea, together is 4 minutes. So that's what we need to do. Then I will talk about the strategy. If it takes the cold faucet by itself 12 minutes, so this one by itself 12 minutes to fill the tub. So if you just turn on the cold faucet, you will take 12 minutes to fill this tub. How long will it take the hot water faucet to fill the tub on its own? So here we know together, we know the cold, and the question is about the hot. So this problem can vary. It could be the other way again. It could be you're given together the hot and you ask for the cold, or you're given the cold, the hot, and you ask for both of them together. So it doesn't matter what it is, as long as we understand what's happening. So one strategy is, of course, to figure out this. The way I did it is to figure out what the question is about, and maybe we'll keep the variables same. Together is T, hot is H, cold is C. And there is one thing that we need to understand. If they're helping each other, should the time decrease, or should it stay the same, or should it be more? That's a very important question to ask. And since there is a teamwork, then the time should decrease, right? Because they're helping each other. If the cold faucet takes 12 minutes, on its own, you will do it on 12 minutes. Let's say the hot one takes 5 minutes. It will not, give a good of anything to say, well, 12 plus 5 is 17, and now together it will take 17. That doesn't make sense, because cold by itself takes 12 minutes. So that will give you an understanding that the equation you will set up is going to be a rational one, which means indirect relationship. You're not going to do T1 plus T2 equal T3, right? You're not going to do cold plus hot equal together, right? So it's an opposite relationship, because the teamwork decreases the time, it's more efficient. So this is kind of the equation that we need to set up. All right, so if you do it this way, it's a direct relationship. They add up, they increase, right? This one is opposite. So this is kind of a general equation to set up all the time. There are a few other ways to set it up, but this is a simple one, where you have once here, which they stand for the rate of doing the job. Because 1 here stands, the rate of doing job for the cold is 1/12, right? And so there is more if you want look into it. As I mentioned, these are review questions, not teaching from scratch. So you can check out more examples and all that, or you can even check out online some more problems. And there are some other ways, but this is a simple one. So let's set it up. 1, and together we know it's 4. H is missing, and this is 12. All right, so it's a rational equation. It has in denominator 12, H, and 4. There are a few ways to solve this kind of equation. One of them is to clear fractions. And we can clear fractions by finding least common denominator for all of them. So we have 12 and H and 4. So we need something that divides for all of them. If you know it, that's quickly, that's fine. If you're getting stressed about it on a test, then you do 12 times 4 times H. And in that case, it's not the least common denominator, but it's a common denominator, right? So I'll give you a second to think about what is the least. So if we do 48H, of course, it has to have all these numbers, whatever you have. This is a common denominator. It also works, right? I did 12 times 4 and times H, that gives me 48H. If you use this one, it will work. You will need to simplify at the end. So did you find the least common denominator? Well, to find least common denominator, you just look at H is going to be there because it's just a letter, but 12 and 4, so you'll think about back, hey, if I have to add these two fractions, the common denominator is going to be 12 because you just need to multiply this by 3 to get that 12, right? So we can actually use just 12H. So either way, you will get the answer. So I found 12H, step 2. So step 1 is to clear fractions by using LCD. So step 1 is to find the LCD. Step 2 is to multiply the whole equation by the LCD. 12H times the whole thing. This way you don't affect it, you don't change it. What does it mean to multiply all that? So this is 12H over 1, which means 12H is multiplied by the numerators and not the denominators. So 12H times 1 over 12. 12H times 1 over H. 12H times 1 over 4. The fourth step is to simplify. Then you will simplify. Right, so here you multiply all by LCD or CD, whichever you find. Then you simplify, which means you are going to divide. So 12H by, so maybe we change back to blue. Yeah, that gives us H. And this H with H cancels, that gives us 12. And this 12 by 4 is 3H. So these must simplify. If they don't simplify, that means the LCD is not correct. All right, so we subtract H both sides. And we get 12 equal to H. Then we divide by 2 both sides. And we get H to be 6. And whatever it's talking about, if it's minutes, then it's minutes. If it's hours, then it's hours. We're consistent here because this is minutes and this is minutes, right? So this is 6 minutes. That's very important to watch for, although we don't have many of these examples here, but if you go to your areas and now one in minutes and one in hours, you have to have consistent units, and your answer will be in that consistent unit. Then you can convert it back to whatever is needed. All right, so does this make sense? Let's see, 6 minutes, right? If this one 12, this one is 6. So if the 12 helps the 6, together should be less than a 6, because the hot faucet by itself will do it in 6 minutes. So if another faucet helps, it should take less, which is 4 minutes. And that's the critical thinking, and that's the reasoning, and that's how the understanding happens. So if we did not do something correct, then it will show up here. And of course, you can check this by putting 1 over 12 plus 1 over 6 should equal to 1 over 4. And of course, for the first example, if it's half, that's probably the only thing I didn't talk about that one. But of course, if it's half, then what do you think we should do at this step, right? If it's double, is 2y0. If it's half, then it's going to be 0.5 y0 or half y0. That's right. That's what you will do, which means you will set it up and you will cancel y0. All right, so we have a compound interest, and there are different types of interest that you see in the course. You see a simple, you see a continuous compounding, and you see a compound interest. Each one works in a way, and it has a different application to it, or a different purpose from using it. And compound interest has its own formula, but this problem can be solved with using the formula or just using the understanding of it. So we have Kareem places $2,000. So this is what we usually call the principal in an account that pays 9%. Interest compounded each year. Each year means n equal 1 if you're using the formula. Once a year it gets compounded. Assume that no withdrawals are made from the account. So it's good that this is mentioned, but if it's not mentioned, you're going to assume that anyway. Otherwise, something else has to be mentioned, the amount that was withdrawn. Follow the instructions below. Do not do any rounding. So find the amount in the account at 1 year. Well, at 1 year, it's almost like acting as a simple interest since it's compounded 1 year. If it's compounded in the middle, like semi, it's going to be affected. But since it's 1 year, that means it's like a simple way of doing it, where we're going to say this is the principal and times that 0.09 and what happens. So it's 180. So the interest in 1 year but here the question is about the amount in the account. There is $2,000 already in it, plus now 180, right? So it's 2,180 in it. Second question, find the amount of the account in the account at the end of the second year. So this is really a good exercise to understand what does it mean compounded. Because if this is a simple interest, right, you will just use the PRT thing formula, principal times rate times T in years. But here, to understand what compounded means, so here for the B, since now in the account, since now in account or after 1 year, there is to 180, that means during second, interest is calculated based on 2180, not 2000. You see, so there is interest, now there is interest on top of interest and principal now. And that's what compounded is, right? So now we're gonna do 2180 times again 0.09. So 2180 times 0.009. 196.2. So 2180 plus 196.2, it's 2376.2. And this is important to watch. Do not do any rounding. We didn't have to do any rounding. So if you're doing something and now you find yourself you need to round, that means something was incorrect with the calculation. So I would recommend also you can try this problem using the compound if you want to try this. In T, this is a compound interest formula where A is the future amount and this one is the principal and R is the rate in percent. So 0.09 and N is going to be 1 because it's compounded yearly, and T for A it's going to be 1 and for B it's going to be 2. You can try this as well. So if the question now why the formula is useful, because somebody says, well, if I can do it this way, it's just easy and forget about it. But it's going to be useful. Let's say this is a mortgage, for example, and you need to figure out what happens after 10 years or 15 years, right? So are you going to do this manually? You do year 2, figure out what it is, you do year 3, 4, and so forth, or you're gonna just use the formula. So that's where the power of the formula will be will come in, where you just put 10 there and you get your answer in one formula instead doing this many times. All right, I think this video is finished. If you have questions, let me know. Thank you and good luck.